In a previous video, I showed you some transistor-based circuits to detect wireless energy at 500 kHz. Here I'm going to show you the poor man's way of doing it, in case you have no money or just want to have some fun. Watch this. Let's explain now how that works. Here we have a solid-state Tesla coil, 16 turns in the primary, 1000 in the secondary, which is being powered by this flipping MOSFET at about 500 kHz and an NPN-PNP driver. The driver is at 4.7 volts. The primary coil is at 10 volts and about 1.3 watts. Out of the top of that secondary coil, we have a test wire that comes over here to this aluminum plate and lights up this light bulb. Now, that energy will not go very far through space. So the question is, what happens if we put an aluminium bar here, 8 millimeters, and put a G4 LED on it? Nothing happens. But when I touch this wire here, then it lights up. The reason is I'm providing a path to ground for current to run through the LED. So we're detecting wireless energy in this very simple way. The next thing I did was to attach the end of that G4 LED to the black wire, return wire of a DC power supply, which is turned off but plugged in at the wall to get a more efficient ground. And you can see now it goes over a considerable more distance of about 18 inches, and the bulb glows quite nicely. It's coming from over there. However, if we take this aluminum rod and move it several feet away from the source of wireless energy with its G4 LED attached and a black wire going into the ground on a turned off power supply, light becomes rather weak. Can we make a different antenna to fix this? What I did next was to get some long pieces of aluminium slightly over 1 meter and run those through a G4 LED into the return black wire of a power supply that's turned off but plugged in. And now it picks up energy from this source way over here, 500 kHz, come way back over here about 3 or 4 feet, and it picks up the energy quite nicely with slight current going through the LED. So if the aluminum rod's a bit longer, it works quite well. I also found this aluminium plate of about 1.2 meters, 1.6 millimeters thick that I got from Bunnings Warehouse, and it works the same way. The G4 LED lights up quite nicely as long as it's grounded through the power supply or through a switch. And the source of energy is way over there, big antenna, and you get lots of light in the G4 LED here. Now while you're doing this, if you touch the plate, you see the light goes out, because now you're getting an alternative path to ground through your body, and the current goes to your finger instead of through the LED. You can't feel it, but it's going through your finger. Of course, if you still prefer to use transistors, it's very easy to make a circuit where wireless power from this bulb here, which is made by a small Tesla coil, is received by another circuit over there with 2 transistors. When we turn the power off, you can see the lights over there go off. We turn the power on, the lights over there go on. This circuit has 2 transistors, 2 LEDs, and outputs 447 kHz wireless power based on receiving a signal from way over here through the air. It only runs on 3 volts DC. So we get a lot of amplification here from 2 transistors. NPN-PNP is a push-pull circuit, and I've tested this circuit to make sure it's amplifying correctly. It comes out here at about 1 volt AC, about 447 kHz. So this is also easy to make. You can do it with aluminum bar or with transistors. Let me show you the circuit for the transistors, and then we'll end this particular video.